The objectives in this lesson is to be able to solve problems involving symmetry and transformation. We will be able to determine whether a figure has been translated, reflected, rotated, or dilated.
Have you ever seen a real live dinosaur or dragon? You haven't, because scientists have determined that dinosaurs lived millions of years ago. And you know that dragons only flared their nostrils and breathed fire in fairy tales. But that doesn't stop animators from trying to bring both creatures to life on film. Using computer animation and motion geometry, artists take dinosaurs and dragons from science and fiction to the screen.
Go behind the scenes to see how the biggest special in Animal Planet history was created.
They transform geometric shapes using translations, or slides, moving a shape from one location to another without changing its orientation, size, or shape. Rotations, or turns, making the figure rotate about a single point or axis along a circle. And reflections, or flips, reflecting one shape to the other side to produce its mirror image. These transformations help artists build the creatures on screen with depth and the sense of motion, making the animals and their worlds look real.
We set out to make dragons as convincing as possible.
Let's have a look.
We'll start with translation, but first, let's talk about what a transformation is. A transformation occurs when a figure changes or moves. The figure before the change is called the pre-image. Pre means before. The figure after the change is the image. A figure that does not change size or shape is called an isometry. Does not change size or shape. So it creates a congruent figure. Now we can talk about translation. A translation is a slide that moves every point of a figure the same distance in the same direction. This is an example of a translation. Notice this triangle right here. This is triangle ABC. We know that this is the pre-image because this is the figure before the translation. How do we know this is the pre-image? Because the image will always have these prime marks. These are called prime. We will say this right here as A prime. A prime, B prime, C prime is the triangle after the translation. So how is this pre-image translated? It looks like it was translated to the right and then down. Notice that any point I pick, such as maybe point B next, will translate the same amount in the same direction. Point B translates to the right and then down to make the image point B prime. So we can say triangle ABC is translated right and down to make the image triangle A prime, B prime, C prime. Notice that this triangle and this triangle are congruent. This is an isometric transformation. It is an isometry because it does not change size or shape from the pre-image to the image. Let's take a look at a problem on a coordinate plane. Graph the pre-image and the image by using the following rule for the translation. X comma y maps to x minus 3 comma y plus 2. This is telling us how the x and the y will change. Let's start by graphing the pre-image. The vertices of triangle ABC are A, 1 comma 1. Let's go find that point. 1, 1. We'll mark it with A. B is 3, comma 4. 1, 2, 3, 1, 2, 3, 4. And C, 5, comma 0. 1, 2, 3, 4, 5, 0. And this is triangle, so we'll connect the points. There is our pre-image. Now, it is telling us that we're going to change the x by subtracting 3 and the y by adding 2. So if we take point A, the point 1, comma 1, we're going to subtract 3 from the x-coordinate. So the 1 is the x-coordinate minus 3. That makes negative 2. The other one is the y-coordinate. So we're supposed to add 2, and that makes positive 3. So the image is the point A prime, negative 2, comma 3. And we'll write next to that A prime. Now notice, from point A, we could have said minus 3 means I'm going left 3 units. Plus 2 in the y direction means we're going translating up 2 units. So from point A, I could have gone 1, 2, 3 to the left and 2 up to find that coordinate as well. For point B, which is the point 3, comma 4, I subtract 3 from the x and add 2 to the y. So point B prime will be 0, comma 6. Or I can go 1, 2, 3 left and up 2, and there is point B prime. Either way, I get to that point 0, comma 6. Let's find point C, 1, 2, 3, 1, 2, and there is C prime, the image of point C. Now I can connect the points to create the image of triangle ABC. Notice that it looks like this entire triangle has been shifted left and up to create a congruent triangle that has been translated left and up.